Okay, so number 9, we're going to take the antiderivative of x cosine 6x squared. So what we do for this one is, once again, we go through these steps and we go, okay, use substitution. Sorry, we do algebraic method. Okay, so there's nothing really to simplify. We try to do use substitution. So we let u be anything inside a function, and in this case, it's going to be the whole thing, including the square. So we're going to let u be 6x squared, because the squared is also inside the function. So we can rewrite this as u equals 36x squared. The derivative of u would be 72x dx. Okay, so we're going to solve for dx, and we substitute everything back. So we're going to have x cosine of u, and instead of dx, we're going to have 1 over 72 du, 72x du. So my x's cancel, and then that's 1 over 72 cosine of u du. So now to find the antiderivative, I bring 1 over 72 down because it's a coefficient. The antiderivative of cosine u is positive sine u. And if I substitute u back, I can either rewrite it as 36x squared or 6x squared. Okay, so number 10 says a particle with velocity at any time t given by this function moves in a straight line. How far does the particle move from 0 to 5? Okay, so this is another way of saying, okay, how far does the particle move is find the area under the curve between 0 and 5 of my velocity. Because remember, the area under the curve is the distance traveled for the particle. Okay, remember when we did our project. So we're going to take the area under the curve. So again, we can't do this algebraically. We're going to try to use substitution. So u is going to be 6t, du is 6dt, and 1 over 6 du is equal to dt. So substituting everything back, and we're going to go ahead and do a change of variables as well to make it easier on us. So when x is 0, u is also 0. When u is 5, when x is 5, u would be 30. So I'm going from 0 to 30 of 2e to the u 1 over 6 du. So 2 and 6 reduces, so I get 1 over 3. The antiderivative of e to the u is e to the u, and I'm going from 0 to 30. So I'm going to write this as 1/3 e to the 30 minus e to the 0, which is 1/3 e to the 30 minus 1. Okay, so find the integral of 0 to 1 of e to the negative 2x dt. So once again, I'm going to do a u substitution. U is going to be negative 2x, so therefore du is negative 2 dx. So negative 1/2 du is equal to dx. Okay, and then also you can do change of variables, or you can just leave them. So this time, let's leave them just so you guys can see how both works versus change of variables and not doing change of variables. So I'm going to have from 0 to 1 e to the u times negative 1/2 du. Okay, because remember, we're substituting for dx. So negative 1/2 is the coefficient, so I just bring it down. The derivative of e to the u is e to the u, and I'm going from 0 to 1. Now, since I didn't do change of variables, I have to substitute u back. So u is negative 2x and I'm going from 0 to 1. So I'm going to have negative 1/2 e to the negative 2, right? We substitute 1, subtract e, substitute 0, so we get e to the 0, so we get negative 1/2 e to the negative 2 minus 1. Number 12 says, if f of x equals the tangent of e cosine of x, then f prime. So this is find the derivative, not the antiderivative. So we're going to find the derivative. So the derivative of tangent using the chain rule is secant squared. Everything on the inside stays the same, times the derivative of the inside. Okay. Well, the derivative of e to the cosine x is e to the cosine of x times the derivative of the inside. So we use the chain rule twice. So the derivative of cosine is negative sine. So it's going to be negative sine of x times e cosine of x times secant squared e cosine of x. Okay, for number 13, we're going to take the integral of x minus 2 to the third over x squared. So the first step is, remember, you always try algebraic method. Second step, substitution. Third step, integration by parts. So I'm going to do algebraic method. So that means I'm going to have to find what minus x minus squared, x minus 2, sorry, and x minus 2 is. Okay, so we're going to have x squared minus 2x minus 2x plus 4. So we end up with x squared minus 4x. So we're going to have x cubed minus 2x squared minus 4x squared plus 8x plus 4x minus 8. So combining like terms, so now what I can do is I can break them apart into 4 separate terms. So I'm going to have x cubed over x squared minus 8x squared over x squared plus 12x over x squared minus 8x squared. So now that I break them apart, I can simplify, and then I'm going to take the antiderivative of each individual one. So I'm going to have x minus 8 plus 12 x to the negative 1. I'm just moving it up, minus 8x to the negative 2. So the antiderivative of x is x squared divided by the new coefficient. The antiderivative of 8 is 8x. The antiderivative of 12x to the negative 1 should be 12 ln of x. And then the antiderivative of 8x to the negative 2, we're going to add 1 and divide by the new coefficient. So I'm going to have 8x squared squared, x squared over 2 minus 8x plus 12 ln of absolute value of 12 plus 8 over x. Don't forget your plus c. Okay, so number 14. Suppose that f and g are continuous functions such that, okay, so this is true. Which of the following must be true? Okay, well, I have a product, and when I have a product, I cannot break them apart. So I cannot have the integral of 5 over negative 1 gives me negative 5. So that is wrong. Remember, I have a quotient. So in order to undo this, I would have to do U substitution, integration by parts, or algebraic methods. So there's no way that this can be true. It might be true, but with the information given, I don't know. So let's try 2. Um, so the 4 is the coefficient. Bring it out. And then the antiderivative coefficient. So we're going to bring it down. And the antiderivative of h of x from 5 to 6 would be 3. So that gives me 12. So that checks. Okay, so the next one would be the antiderivative from 2 to 5 is negative 4. Well, I know, right, since we're doing h, I know that from 2 to 6, the area under the curve is negative 1. And from 5 to 6, the area under the curve is 3 of h. Okay, so we want to know the area under the curve from 2 to 5. Okay, so that has to be negative 4, because negative 4 plus 3 will give me negative 1, so that checks. So the only thing that's correct is 2 and 3. Okay, so let's look at 15. Use geometry to find the average value of the function. Okay, so remember that the average value is 1 over b minus a from a to b of f of x dx. So here's a and here's b. I'm going to have 1 over 4 minus negative 4 of negative 4 to 4 of g of x dx, which is this. And this is just find the area under the curve from negative 4 to 4. So if we find the area under the curve from negative 4 to 4, we're looking at this area. So we're going to have 1 over 8. And in order to do this, we're going to do figures. So we're going to have a big rectangle. Okay, let's erase this. So we're going to have a big rectangle that has a base of 8 and a height of 5. And we're going to subtract the semicircle that has a radius of 4. So the area of the rectangle is 40. The area of the half semicircle is pi times radius squared divided by 2. So that's going to be 40 minus 16 over 2 pi, or 40 minus 8 pi. Okay. So that is the area under the curve, but don't forget to multiply it by 1 over 8. So I'm going to have 5 minus pi. That would be my average value.